So we were speaking the last time about count, how to do aggregation in Neo4j. And we mentioned how we don't need an explicit group by. It has this rather nice feature that implicitly, whatever is, well, one can argue if it's nice or not, but it makes a lot of sense to me. So you don't have a group by, but whatever is not used in an aggregation function like count or max or min, or standard deviation and so forth, is implicitly the group by for the query. So in this case, we're looking for x1 knows transitively x2. So x1 will match Julie, in which case x2 would match John, Julie, and Frank, and so forth. And we're returning the first name of x1, and we're counting x2. So for each first name, how many people they transitively know. Okay, so for Julie, we would expect 1, 2, 3. For John, we would expect 1, 2, 3. And for Frank, we would expect no results. So, for John, we have 4. Let's see if we can find the fourth one. So we have 1, 2, 3. We also have, why 4? So we have 1, 2, 3. Okay, sorry, right, yeah. So we have this this connection to Frank. We have Frank twice because we have Frank once using this result here, and he also appears again because of this path here. Okay, so because of this path here, the direct one and the indirect one, which doesn't reuse an edge, we have Frank twice. So we'll have John 4. Okay, so this is an example for count. So in this case, we remove the duplicate results with distinct, right? So, but we do not remove the duplicate count arguments here. So we compute these results and then we remove the duplicates, but we see there are no duplicates. So if we want to count distinct values, we have to put it inside, much like in SQL, inside the distinct keyword inside the count function. And in this case, we would expect Julie to have 3 and John to have 3. So this is count. So this would remove the duplicate count arguments. So that was an example of aggregation. In terms of other functions we have in Cypher, there's a long list of different functions that Cypher provides. But to give an example, to take an example of one that's interesting in the context of graphs in particular, we'll focus on this one here. We can use a function length to return the length specifically of a path. Okay, so this will return in this case length, which is a number like 3. So what is the path looking for? It's looking for the length of the shortest path between Julie and Frank, effectively, or sorry, from Frank to Julie, a directed path. So let's see, we have 1, 2, from Frank 1, 2, 3 in this way. So Frank, sorry, doesn't count. So we have a length 1, length 2, length 3. So a direct path, just one edge, would be a length of 1. So it's essentially how many edges we traverse in the path. So there's a wide range of other functions that you could find in the documentation. So with respect to updating graphs, thus far we've spoken a lot about querying graphs. How to update graphs, just very briefly, to mention some of the commands that we have in Neo4j. We can use create to create nodes and relationships. We can use delete to remove nodes and relationships. We can use detach delete to delete nodes and their relationships, the relationships on which that are incident on those nodes, that involve those nodes. We can use set to update some labels and attributes, the metadata for associated with nodes and edges. We can use remove to remove labels and attributes if we just want to delete them, and so forth. So these are the main commands here that we have. So in terms of some examples, just of some of the main types of commands, here's the graph, essentially the commands to create the graph that we've used in the class. So here we see we create the nodes, all of the 5 nodes that we saw in the example property graph that we've used. Then we create the edges, right? So what we're doing here, first of all, we can also use a match to be able to identify the nodes that we want to join. So we're going to match N1 to Julie, N2 to John, N3 to the tag, N4 to the post, and N5 to Frank. And then for each of these results, we'll apply these functions. So we create an edge from N1 to N2, N2 to N1, and so forth. And within the edges, we can also add our metadata that we want to include on the edges. If we wanted to delete all nodes and edges, well, we can use the detach delete function, which will essentially, here we match all nodes, and then we say detach delete n, which will remove all nodes and all edges incident on those nodes, all of the edges that go to or come from each node. So these are the basic commands for updating graphs. So any questions for that? It's all relatively clear. Okay, so that's the core of Cypher. There's a lot more details like the functions that we haven't seen, but this is the core of the query language. And this is one part of Neo4j. So Neo4j has a lot of different features, and it's adding more all the time for querying and processing and analyzing graphs. So again, as I mentioned before, the data model is property graphs, which we've seen lots of examples of. We've spoken a lot about Cypher. And Gremlin, we can see a quick example of. It's sort of like a scripting language for kind of navigating in a graph. And yeah, so we'll jump into this, comparing Cypher and Gremlin. So Cypher we've seen is the language we've seen in all the previous examples. It's sort of a little bit like SQL. It's quite declarative in a way. Okay, it has some significant differences from SQL, but you know, we still have things like union, all. We still have aggregations and count and so forth. So there are definitely some similarities, and in general, it's a sort of a declarative, more declarative language. So we see our query here, original query, and the results. If we compare this with Gremlin, Gremlin has a flavor much more like a programming language, much more like an imperative language. So we can call functions. We have a graph object, and we can use .v to reference all of the vertices or nodes in the graph. And then on that set of vertices, we can call functions like filter to only return the vertices that have first name Julie. Then we can go to the vertices that link to Julie, and then we can navigate out edges with the nodes relation, and we can do that recursively. So essentially, this is sort of like all of the people that Julie knows transitively in the graph. Okay. So it has a more imperative style. So this then allows us to, N2 essentially allows us to apply the recursion until no results will be found, until there's nowhere else to navigate to effectively. So Gremlin is not only supported by Neo4j, it wasn't proposed by Neo4j, it was proposed in the context of a separate project, and it has been implemented in a variety of graph database systems. And it's often used, for example, for calculating graph algorithms, such as, for example, PageRank, these sorts of analyses on graphs. However, one can also, as we see here, do queries in Gremlin, and one can, to a certain extent, do certain types of analyses using Neo4j with the functions that are available, such as finding shortest paths, computing degree centrality, which is just finding for each node how many edges go out, and so forth. But yeah, so in general, how graphs are used. Um, in databases, we have this idea of online transaction processing, which is your typical kind of relational database or database system scenario, which is where you have lots of transactions like queries, inserts, updates. You could have thousands of them, per minute, for example. You want to process them as efficiently as possible while providing some guarantees. At the strong end, that would be something like ACID, the ACID guarantees of relational databases. On the other hand, we have online analytical processing, which refers more to applying aggregations over large sets of data. For example, we have a database of products, and we want to be able to find out how many times that product has been bought at different hours. So each transaction we can consider as being like accessing a small subset of the data, the overall data. Here, the analytics could involve a large chunk of the data, or all of the data, potentially. And we can actually use Gremlin in some sense in both modes. We can run it in terms of online transaction processing, or we can run it over things like Spark as well, Giraffe, to have something more like an online analytical processing framework. So again, this is sort of for queries that will touch a small amount of the data and return few results, but where we have a great many of those sorts of queries or transactions. Here it's for more large scale analyses that will touch a large fraction of large data sets. Is the general kind of difference between both of these. So that's the class on Neo4j on graphs in general, graph databases. Any questions or doubts? If not, let's just start the lab. So we'll pass to Discord. So see you in the Discord for the lab. In the lab will be queries over Neo4j using Cypher.